So for polynomial regression or quadratic regression, whenever you see that, go ahead and use any free online software you can find. You could do it in Excel apparently, but I looked into it and it takes a long time. And this, it's just not something that you would probably do every day in some sort of job, but it's something you should be aware of that's being used to make decisions. Right? The big idea is that let's get data set real quick. I won't take long, and I know you want to get right to solving problems, but if you've got a data set that looks like this, in a chemistry class, you might have learned about the line of best fit, and the line of best fit for this data might be here, right? But the data would be better fit by a parabola, and that's what quadratic regression can do for you. And that's kind of like a segue into statistics. If you ever take a statistics course, you don't have to just model things with a straight line. There's lots of different cool ways we can model stuff. But let's get right to getting this question right. Quadratic regression calculator. I'm just going to Google first one that comes up. There's tons of these online, so if this one doesn't look cool to you, that's fine. Let's clear what they have. Maybe we can copy and paste this. No, we got to type it in. That's weird. They don't let you copy and paste it. Okay, I've got the x variable plugged in. Time is always an independent variable because we can't influence time unless you can make some sort of theory of relativity argument that I don't know about. And then we got the y variable plugged in. If we hit execute, it gives you the coefficients. Okay. Oh, sorry, I missed something here. They said they wanted x, so I didn't get the same thing. I got negative 7,000 for coefficients, but they wanted x equals 1 to be 2005. I missed that. So 1, 2, 3, 4, 5, 6. Okay, let's see what we get now. Okay, so I don't get the same A as them. Oh, okay, so for this one I pulled up. Look, A, it's not conventional. A is usually the coefficient of x squared, but in this, A is the number hanging out all by himself. B is the coefficient of x, and C is the coefficient of x squared. So my leading coefficient is negative 1.8, which is why this is selected, and that's the correct answer in Newton. Okay, so you can use any software you want, but you got to look out for weird things like that. Like that's not conventional for math. A plus bx plus cx squared is usually ax squared plus bx plus c. But we got the right one. Look, the coefficients correspond to the correct answer. Negative 1.8 is the coefficient of x squared. Negative 1.8 is the coefficient of x squared in the correct answer. You can match up the rest of them. Let's do another one. Okay, this one, data is just given to you in a different way. It's x and y pairs, so negative 2 is the x, negative 1 is the x of the next one, 0 is the next x, 1, 2, 3. Okay, and then here we've got 8, 4.6, 2.5, 4, 5.6, and 10. If we execute, we'll just have to remember I've found some sort of weird one. The leading coefficient, C, in this one is 0.96. Looks like all the options have 0.96, so that doesn't narrow it down. My B off to the side of the screen is negative 0.546. So that means it's either this one. Oh no, it's this one right here. That's not quadratic. This last one. That has a cube variable. So that'd be, I guess, cubic regression. So that's the correct answer right here. Is that all they want for this one? I guess so. Okay, and I think that's all they're looking for you to do. So again, this topic is in here just to expose you to it, to see, you don't just have to draw a straight line to best fit the data. We have technology, we have techniques to help us find a curved line like x squared to help us best fit the data.